Okay, so this question here is just asking, of these four components, which is the most acidic? So which is most acidic? So with that, let's find out which ones they're talking about. Okay, we have this thing, so double bonded oxygen just right there, and then we have this thing, double bond oxygen but with an OH pair right there. We have this, which is very similar, but this is missing an O minus. Okay, this is a way of tracking it. And then as the last one, we have an NH2. So let's break it down by which is most acidic. So let's start with which ones can actually give away hydrogens. Alright, so with that being our first indicator, this one's out, because carbons usually aren't the ones to be given hydrogens. You want to be able to see like an oxygen trying to give away a hydrogen. Alright, so that one won't work. And with that logic, this one also won't work because it has no hydrogen to give. Carbons bonded to hydrogens, those ones don't count as hydrogen bonds, which is what you're looking for. You want, because things, the hydrogen bonds, those are the ones that are bonded to like oxygen, nitrogen. Okay, those two are the hydrogen bonds that you're looking for in these cases most of the time. So with that, this one, oh look, it has hydrogens, and this one also has hydrogens. So these ones are contenders currently. Now, before we hop straight to the answer though, NH2, this actually works differently in terms of its hydrogen bonds and everything, because what it prefers to do, instead of giving away a hydrogen, it likes to do what I call, taking one. So what it prefers to go to is NH3 plus. I'm sure you've heard of it. So this right here is ammonium, okay? And that's what it likes to do right there. So NH3 plus is going to be what it likes to do over there. Alright, and because it likes to take a hydrogen instead of giving it away, that would actually make this a base. This will be basic. Alright, so this is no longer a contender. Now this oxygen, what it likes to do, funny enough, they actually gave you the answer next to it, because this is the form it would take. It would give away this hydrogen here and just be an O minus. Now you're probably wondering, okay, but why would it give it the oxygen? I mean, why would the oxygen give the hydrogen? And why in this scenario, let's say if we had this is one of them, why would this one work? Because this is actually an alcohol. This one wouldn't work because there's no resonance structure. This oxygen is in a really awkward position to give away a hydrogen. It doesn't just want to be negative, it wants to be in a balanced state. When you give away that hydrogen while you have this oxygen, you end up with a structure like that, where these two oxygen just kind of sharing that double bond. And this resonance structure is what makes those type of molecules be able to do what it can do. And that's why that's the most acidic. Now, fun note is that if you actually got comfortable with the nomenclature, you'd notice what to call these. So this is a double bond here with two functional groups on the left and the right. So this right here is a ketone. Alright? This, funny enough, is actually called a carboxylic acid. And so right off the bat in its name, you know, this is going to be the most acidic, most likely. This right here is this thing's conjugate base, as we discussed earlier. So if this was HA, let me just write it a different color. I'm trying to think. No, actually, blue works. If this was HA right here, this carboxylic acid, this would be its A minus. That's pretty much what it is. And that means it wouldn't work because it's already done its job of giving away the hydrogen. And now as the last thing, this right here is an amide. And most of the amides are basic. So if you kind of were familiar with nomenclature and you could actually recognize them based on their formula, you could actually then also figure out which is the most acidic. So now let's see what they have here in terms of the answer. So this one, as they also mentioned, the first one, the ketone, as we discussed, it's not able to give away any of its hydrogens because it's bonded to carbons. Those don't count as hydrogen bonds. Now they mentioned the OH. It's able to give away its hydrogen. This is going to be probably the most acidic. Now this one, the conjugate base, is already done its job. Can't do it again, so it's not going to be acidic anymore. And NH2, it's actually basic, as we discussed. It wants to turn to NH3 plus. Okay, so with that logic, as they said, which is correct, 2 is the correct answer. So let's continue.